Okay, we're now on to factorizing and solving cubic equations. We're very familiar with factorizing and solving quadratic equations. And when we had a quadratic equation with an x squared, we did our double brackets, let it equal to 0, and then either the first bracket was 0 or the second bracket was 0. For cubics, we're going to have 3 brackets equal to 0. And then we'll fall into those same old steps again. The first bracket equals 0, second bracket equals 0, and the third bracket equal to 0. But there's quite a bit of work to be done to get it into this factorized state with the 3 brackets. So how are we going to do that? I've written the steps up here for you. The first step is to factorize it. This is the difficult part. In order to factorize it, we're going to need to find one of the factors by using the factor theorem. We know that if x minus k is a factor, then f of k is equal to 0. What we need to do here is we need to find some value that when I sub in here is going to give me 0. You can do a little bit of guesswork if you like. Generally, it's going to be either f of 1, f of 2, f of 3 at the most, or possibly the negative versions of those. They're not going to have you doing trialing lots and lots of factors in an exam situation because it wouldn't be an efficient use of your time repeating this step over and over again. One little hint you can do to help you is, if you think about these 3 brackets when they're multiplied together to give 0, the last part of them, if you were to expand the bracket, the last part would multiply together to give 3. So the end parts here are likely to be 1, 1, 3. Try maybe f of 1 or f of minus 1 or possibly f of 3 or f of minus 3 would be a good place to start here. Let's start with the 1 because that's probably the easiest one to try. It mightn't always work out on the first go, and if it doesn't, we try again. All right, we are going to try f of 1. I know we've got our equation here equal to 0, but to use the factor theorem, we need to just convert it temporarily into a function. Okay, so f of x is x cubed minus 3x squared minus x plus 3. F of 1, is that going to give 0? Which is 0. So that tells us, remember there's the sign change thing. If f of 1 is 0, then x minus 1 is a factor. So looking at our steps, we use the factor theorem to find one factor. Part B then of step 1 is to do long division to find the other factor. So long division. If x minus 1 is a factor, then it will divide in to my cubic with no remainders. And of course, we've already established that it is a factor since it satisfied the factor theorem. Right, let's go back to our steps again. Divide in. All right, this is back to the long division steps. Divide in. X into x cubed goes x squared. Multiply back once and twice. X squared times x is x cubed. X squared times minus 1 is minus x. Subtract. Minus minus. Minus 3x squared minus 1x squared is minus 3x squared plus 1x squared, which is minus 2x squared. Bring down. Repeat. Divide in. X into minus 2x squared is minus 2x. Multiply back to both terms. Minus 2x times x is minus 2x squared. They're matching up. That's good. Negative 2x times negative 1 is positive 2x. Subtract. Minus minus. That goes minus 1x minus 2x minus 3x. Bring down plus 3. Will I go with a different color again? Why not? Divide in. X into minus 3x is minus 3. Multiply back. Come out of there twice. Minus 3 times x is minus 3x. Minus 3 times minus 1 is plus 3. Because it's a factor, we knew there was going to be no remainder. So that should cancel in the end. They should go away. If they don't, you've made a mistake somewhere in your long division. Okay, so what have we got? Step 1, factorize. Use the factor theorem to find one factor. Done. Let me label up my steps here. Step 1. Step 2, long division to find the other factor. Done. Equate to 0. So let me just give you an easy example just to show you something for a second. If you do 12 divided by 3 gives 4, then you can say that 12 is equal to 3 times 4. Okay? We're going to do a similar thing here. If you can say that x minus 1 divides into x cubed minus 3x squared minus x plus 3, giving x squared minus 2x minus 3, then you can say that x cubed minus 3x squared minus x plus 3 is equal to those two parts multiplied together, like the 3 and the 4 multiplied together. Here, the x minus 1 multiplies by x squared minus 2x minus 3 to give me the bit that's inside underneath the bus shelter. It was the 12 in our numerical example, and here it's the cubic. I am trying to solve, step 4 then, I'm asked to solve x cubed minus 3x squared minus x plus 3 is equal to 0. But I know that cubic is the same as x minus 1 times x squared minus 2x minus 3 is equal to 0. I'm going to go one more step because I want all linear factors. The first one is a linear. It's the highest power of x is 1. But here I've got a quadratic, so I'm going to use my double bracket factorization method from way back in Algebra 1 to factorize this. X 3, 1, minus 3 plus 1. Now I've got 3 brackets equal to 0. So that tells me that x is equal to 1, x is equal to 3, and x is equal to minus 1. Oh, there's so much in that, but we got there. Right, how'd you get on with that? Oh, these are tough questions.